Hi, my name is Kenny Hong, and today I'll be presenting on exploring technology to train positive pressure ventilation in neonatal resuscitation. I would like to take a few seconds to just acknowledge the Visual and Automated Disease Analytics Program for funding this project, as well as my co-authors, Yumiko Sakamoto, Ganesh Srinivasan, and Parang Ireni. Already, there was a lot of big words in the title, so at first I would like to introduce the topic of neonatal resuscitation and the problem we are trying to solve. So, annually, approximately 136 million newborns are born. An estimated 10% of these newborns require assistance to breathe. Neonatal resuscitation is performed to help the baby start breathing again. Here's an example of the textbook used in this training. Specifically within the neonatal resuscitation, we'll be looking at positive pressure ventilation, which is also known as bag and mask ventilation. This procedure is meant to deliver air to a baby through a face mask. Neonatal resuscitation training is a large and complex procedure. However, it only takes a few minutes to perform. The renewal of neonatal resuscitation training and certification is required of healthcare professionals every 2 years. This is to ensure a certain standard of care when an infant requires resuscitation. However, previous studies have shown that that skills degrade within 3 to 6 months of training without proper refresher training. Examples of current training includes basic scenario training based on the textbook, delivery room simulations with full audio and visual feedback, and delivery room simulations with full audio and visual feedback. So what is the problem here? We are looking if we can create an accessible tool that facilitates frequent, if we could create an accessible tool that could facilitate frequent positive pressure training or PPV training. The requirements of this tool has to be easy to access or easy to obtain, available to use for frequent training frequently or as needed, and it has to incorporate elements of motivation as well as lightweight feedback. So in this next section, we will be looking at some tools and techniques that we have employed in order to achieve these, in order to see if we can achieve these goals. The first topic that we look at is situated learning. Situated learning is described as learning through scenarios embedded within the social and physical environment where the situation occurs. In healthcare, in situ training often takes place on site and uses real scenarios, real equipment, real people, and real lives. In computer science, in situ is defined as continuously providing a user access to relevant information in various locations and contexts. This research will be looking at different forms of providing feedback to users while they are training. We provide users with relevant information of their performance in real time while using equipment that is commonly used in PPV and hospitals. However, users will not be trained in real scenarios with real newborns for this work. In situ will be in the context of computer science for this presentation. In order to allow our users to see what they're doing and as well as provide information, we look into the use of augmented reality. Augmented reality is systems that enable real-time interaction between virtual and real objects that coexist in the same space, which is defined by Azuma and their colleagues. There have already been examples of simulations with AR. Pratt and his colleagues looked at the use of using the HoloLens to bring a new level of precision and planning into reconstructive surgery. Through preliminary studies, the authors were able to demonstrate that using the HoloLens could help with precise localization of perforating vessels. With positive results and feedback with the HoloLens from the authors, I hope to leverage this technology to help deliver performance feedback to the users of this tool. In order to bring an element of motivation into this tool, we looked into using gamification. Gamification can be described as a method of applying the typical elements of game playing, such as scoring systems and competitive leaderboards, to other areas. McKinnon has found that gamification can improve infant CPR performance. So how did we combine all of these topics and tools in order to create our own tool? Well, first we had to look at the characteristics of the positive pressure ventilation. What are the key points of a successful procedure of this of PPV? First is the timing. In order to be effective in positive pressure ventilation, the timing and the cadence has to be just right. The next is pressure. Too little pressure may not be enough to help the baby or inflate the lungs, and too much pressure may burst the baby's lungs. The apparatus that we'll be using for this experiment is, of course, the HoloLens, a modified resuscitator, a life-form newborn baby, which can be found in many training facilities at hospitals, and also a fidget sensor that is attached to the modified resuscitator. The resuscitator itself consists of a plastic resuscitator that can be found at most hospitals, a teardrop face mask, which is plastic, and the fidget sensor is a gas sensor that measures 0 to 100 kilopascals. So now we had to take the key characteristics and implement them. The timing of the implementation was 40 breaths per minute, and then the pressure that our goal pressure was 20 to 25 centimeters water, or 1,961 to 2,452 pascals, which is the textbook numbers that you'll find in the textbook. The stimuli that we'll be using for this tool for this experiment was a visual stimulus as well as an audio stimulus. The visual stimulus was feedback given through the game's visuals, while the audio stimulus was given through the game's audio. This stimulus was divided into 4 conditions. The first condition was visual only with no sounds, audio only with no visuals, both visual and audio, and then a visual and audio transition condition, which started with visual and audio to start, and then only audio at the second half of the study. We wanted to use the first half of the study to the visual and audio which is the first half of the study, in order to help them learn the rhythms and sounds of the game, as well as then see if they are able to continue the performance consistently with audio afterwards. The visual stimulus consists of a fox running across the screen, and when you compress the ventilator, it will make the fox jump and attempt to hit the crate. There are 3 possible outcomes when you hit the crate. You can either score if you reach within the 20 to 25 centimeter water goal. If you hit too much pressure, you'll get an overshot. Too little pressure will result in an undershot. The audio stimulus consists of a couple of sounds. There's a compression signal to signal when to compress, feedback when you have an overshot, feedback when you have an undershot, feedback when you score, miss the target, miss the compression, hit the target, and as well as a sound when the trial is completed. Here's a little example of what it looks like. So as I compress, we go, and then I compress again to start the game. And now the fox is running across the screen. As you can see in the background, it's the bed. I compress, too much pressure, just the right pressure. Yeah, so that is an example of what it looks like. On the side, there's information on how well you did as well after each trial. Before each trial began, the participants got video instructions on how to perform the procedure by a respiratory therapist who has trained a lot of healthcare professionals in this procedure. Here's an example of what the video kind of looks like. In the background, there's instructions based off of the textbook as well. So the study task is broken into 20 trials with 3 required breaks in between every 5 trials. There are 20 compressions per trial, and the implementation was based on a breathe 2 3 rhythm. Our first study was performed with non-healthcare professionals, and it was performed at our school's laboratory. The bed. We tried to simulate the environment as best as we could, and we were able to get a bed from the hospital itself, and that's how we started with the study. We recruited 41 participants for this non-healthcare professional, 41 non-healthcare professionals. 1 participant did not complete the study, and the average age was around 25 years old. For the results, we focused on data from trials 11 to 20. We wanted to give them sufficient time to learn, and also trials 1 to 10 were removed from analysis based on the visual and audio transition condition. We wanted to give them enough time to study, and this analysis was across all conditions. We first conducted we did find significance. Sorry. So we first conducted Kruskal-Wallis in order to see if there was a difference, and then afterwards, a Man-When-You test was conducted to locate the difference. We found that there was a difference between the visual and audio conditions, as well as the visual and the visual audio transition conditions for compression timing. For pressure performance, compression timing was whether or not the participant was able to correctly compress and achieve compress and hit the target. The score does not matter at this point currently. Pressure performance is whether they were able to achieve the correct pressure when compressed, and there was no significant effect across conditions. Score is when both the timing and the pressure was correct when compressed. We did find a condition effect within the score. The score, we found that visual was better than we found that visual and visual audio was better than there was a significant effect between visual and visual audio transition, as well as visual audio and visual audio transition. The lack of condition effect and pressure accuracy was surprising, so we investigated further in order to look for potential causes. We found that there was quite a bit of missing data in our analysis. And we looked into why this was happening. So one of the possibilities was the mask seal. The baby that we used, as well as the mask that we used, may not be the most comfortable tool. So there may have been some leaks when the there may have been some leaks. So this is an example of how we tested the pressure. We had it completely sealed, and it was, sorry, when it was completely sealed, we were able to get high pressures. However, when we started putting it on the mouth of the doll, the pressure lowered. And then when there was a little bit of leak, as you can see, the pressure lowered again, as well as when our, and now he lifts up the mask, and there's little to no activity at all. So a summary of study 1, the visual condition was superior to the audio and the visual audio conditions for compression timing. No significant effect in pressure accuracy across conditions. The visual and the visual and audio condition was superior to the visual audio transition for scoring. And we found that mask leaks and maintaining a proper seal is important. So this may have been a potential lack of awareness with regards to mask leaks, as well as and the issue of proper seal, which is a core characteristic of positive pressure ventilation. We wanted to see whether it was just because of experience. So we looked into a validation study with healthcare professionals and compared it with the lay people, with the non-healthcare professionals. This study, the second study, the validation study, took place at the hospital itself in the NICU. The difference was that the visual and audio transition and the visual audio conditions were excluded from the study. We only looked at the visual only and the audio only conditions. We did this experiment in the NICU attending's office, and then the bed was similar. It had the exact same functions as the bed that we had at the in our lab, and we tried to simulate the environment as best as possible. We recruited 20 participants from this. We recruited 20 participants for this study. Experts were nurses, respiratory therapists, neonatologists, and doctors. The average age is around 39 years old, 40 years old. For consistency, only trials 11 to 20 were analyzed, and ANOVAs were conducted for compression timing, pressure, and score. We found that there was a significant effect in compression timing, where visual was better than audio, but there was no difference between pressure, performance, and score, which is consistent with the first study. So let's discuss what we found today. We found that the averages between there was no significant difference between the average between visual condition between the lay people and the professionals. We also found that there was no significant effect between the lay people and professionals in audio as well. However, what we did find was that the non-healthcare professionals failed to respond more often with the audio condition. No effect was found between the participants in the visual condition. This can potentially point to two causes. Lay people missed compressing more than experts, and as well as lay people were not able to use the mask properly in consistency. So the focus on audio may be due to the concentration of listening to audio versus concentrating on the mask seal itself. So limitations and how we can improve the tools. Express comments and feedback from the healthcare professionals themselves was that the HoloLens was too heavy, it was hot, and it may include eye strain. The audio signals got confused at times. The mannequin itself was not a proper representation of a baby, and there were some possible leak areas that may have happened. The bag and mask was not used. The teardrop mask is not used as often as the silicone mask in our hospitals in Winnipeg, but however, the teardrop mask is used in a lot of other places, so that the healthcare professionals may not have been used, may potentially not be used with, may not be used to the mask itself, and as well as they pushed a lot. There was a lot of pressure being used for the mannequin itself, and it broke a couple of masks actually. So I had to tape. I just wanted to include a picture of it being taped up. Fatigue was a big deal with this training because they had to adjust and push harder in order to achieve the same pressure. So here's a little example of what of how much pressure that the professionals had to use and how much adjusting happened. See, the professionals adjusted and then pushed harder, and this may have caused the mask to burst at times as well. So future work that we will be looking at is precisely measuring the seal of the mask, as well as alternatives to feedback delivery using a visual stimulus based on the results of the study. We also wanted to look into longitudinal skill retention studies and how we can retain the skills that were learned in this with the tool. The contributions of this project is an initial prototype for accessible tool that facilitates frequent skill training, a new set of requirements to consider for the design of the next iteration of the project, and as well as show that it is possible to create an easily obtainable and accessible tool. Thank you. Do you have questions?
Thank you for your nice presentations regarding for the life-saving research project for the child, newborn babies, and it was a wonderful presentations. Now we'll move on to the question and answer. We'll wait for the Anna. Yeah, Mr. Kenny Hong, you have one questions. Why did you find similar patterns of the results from both lay people and experts?
Sorry, what was the question? I couldn't.
Why did you find similar patterns of the results from both lay people and expert? In the charting, you can read. Yeah.
Why did you find similar patterns of results from? Similar patterns. In the limitations, we talked about not having potentially not having the correct face mask. They were not used to the face mask, as well as this is for visual and audio conditions. So the sounds could have been more confusing. So here, I will go to that slide actually and share my screen again. So that express comments and feedback, these are the feedback from healthcare professionals itself. The HoloLens may have caused performance issues because it was hot, eye strain, it may have caused eye strains and heavy. Audio signals were confusing for the audio conditions for some professionals, as well as the mannequin not being like a real baby. There was a lot of complaints on how hard the structure was, and as well as the bag and mask being not what what different healthcare professional uses different bag and masks, and some of them were not used to the tool used in the study itself.
Yeah, I have one question from you.
Sure.
Before starting the experiment, the non-health professionals, did they receive any training? For
yes.
The non-health. Yeah. Okay.
Yes, of course. Hold on. We will be. So before every experiment, even with the healthcare professionals, we showed them a video with a narrated script approved by a neonatologist, and with a video of a respiratory therapist performing the actual procedure itself, so that they learn and they also had the time to train and get used to the tool.
Yeah, thank you. Yeah, I think we have no more questions. Thank you very much for your presentation. We will move on to the next presenter. Thank you.
Have a great day, everyone.
Yeah, thank you.